So this is a bit of a tricky problem because there's three events going on here. We're selecting a box, we're selecting a first cookie, and we're selecting the second cookie. But we know about the fact that the cookie selected was chocolate chip and not oatmeal, but we don't know which box we selected it from. So we don't know what's going to happen next. So there's some uncertainty about it. So this is what I've diagrammed here. So this is our first event. Okay, we're selecting a box. Okay, maybe I'll label that out. So there's many ways to do this problem, and some people may be able to solve this problem with some intuition. But this is a way we can also look at it. Okay, and I'm just going to use the basic idea that the probability of what we're looking for divided by what's possible is going to give us the overall probability. And not only that, we're also going to now start using this idea of independent events. We can actually multiply probabilities to figure out the chain of these independent events. Okay, so here's our first event. It is selecting the box, right? Here's our first event. And we don't know what happened in the first event. We don't know if we're in A, we don't know if we're in B. But we know the second event here is selection of the first cookie. Okay. We know we didn't get oatmeal, so I've done it in red. We know it's impossible that we went and selected oatmeal on this selection. It's not possible. And I put down the probability. So the probability of going to A or B, in this case random, so it's going to be 1/2, 1/2. In box A, there's 2 chocolate chips. So the probability of selecting the chocolate chip is 2/3 here. The probability of selecting chocolate chip was 2/3 here, 1/3 here. Okay, since there's only one oatmeal, there's only 1/3 chance, but we know that this didn't happen. So we know we can't go down there. Okay, so this is not a possibility. Here, the same thing. There's 2 out of 3 chance of selecting oatmeal out of box B, but we know we didn't go down here. It did not happen. Okay, so it's not a possibility anymore. So I've done it in red. So that's our second event. The third event, okay, since we didn't select oatmeal, we're not going to worry about what happens after the first oatmeal. Okay, because again, although we could draw it out, it actually didn't happen. So we're not going to worry about that as possibilities. Okay, so we're just going to stop it there. So here, this is our third event. This is what we're being asked about. We're being asked about the third event. Okay, we want to have an outcome of chocolate chip on the next draw. So basically, we want to have this one. Okay, because if I take a chocolate chip out of here, there's no more chocolate chips left, and there's only 2 oatmeal left. Okay, so we wouldn't be able to get a chocolate chip out of here. So nothing out of here would give us a positive outcome. Yet, this is still possible, right? This might still happen. Although we don't want it to happen, this actually represents a possibility, right? We select a chocolate chip and then we select oatmeal. It represents a possibility of what could happen. We could kind of say that, well, this is impossible, right? Because it's 0 chocolate chips. So we could also ignore that if we want, okay? Because it actually, although it's, we're saying it's 0, and we could calculate it as 0, we could also just ignore it and say, well, it doesn't happen. So how do we then work out the probability here? Well, since these are consecutive events, I can actually see what the chances are of getting this. So that's what I'm going to do. I'm going to work out this probability by working out the probability of getting A, which was 1/2, getting a chocolate chip out of A, which was 2/3, and getting another chocolate chip because there's still 50% chance of getting chocolate chips. So it looks like this: 1/2 times 2/3 times 1/2. So the probability of this happening works out to be 2 out of 12. Okay, so that's 2 out of 12. So that's what we're looking for. That's what we're looking for. That's what we want. Okay, we wanted this to happen, and we wanted to end up with this. But the problem is, this is the probability of this happening from the very beginning. Okay, and that accounts for being able to go down here, but we know that that couldn't happen. So we can't actually include that as part of possibility. So this is what we're going to do then. We're just going to figure out the probability of everything happening. that all the possibilities that we know could happen, we're just going to calculate those ones. So this could happen. We can get a chocolate chip oatmeal. Okay, so that's going to be a chocolate chip, which is 2/3, and oatmeal. Okay, so this is 2 out of 12 as well. And we know we could have also done this. Okay, we couldn't have gone down here. We couldn't have gone down here. We couldn't have gone down here. But we could go B, get a chocolate chip, and then we would have had to have gotten an oatmeal. Okay, so it looks like this: 1/2 times 1/3 times 2 out of 2. This is certainty, right? So we know that's 2 out of 12. Okay, so the possibility of this happening is 2 out of 12. So these are all the possibilities. This is everything that could happen. Okay, it could happen. This could happen. This could happen. This could happen. And if you look at it rationally, well, there's 3 events that could happen. They're all equally likely, and we got this one, so we can say the probability of the next being chocolate chip, probability of second chocolate chip must be equal to 1/3. We could do it that way. We could do it even more formally. Okay, we could look at it like this. Okay, so 1/3 is the answer, by the way. The other way I can do it is I can do this. I can work out the probability of what I want. This is my probability of what I'm looking for. And the probability of what's possible, okay, so divided by all the possibilities. Well, not everything's possible. Only the first one plus the second one plus, in fact, I should do that one in blue because this is the one that we're looking for. That represents part of our sample space. There's actually 6 out of 13. Okay, so the probability works out to be 2 out of 13 divided by 6 out of 13. Okay, so we'll just rewrite that as 2 out of 13, and we'll multiply by the reciprocal, cancel those out. The probability works out to be 1/3. Okay, and so if you wanted to just do a simpler analysis, we could have just said the 3 possibilities that could have happened, they're equally likely, so I only want this one out of the 3. We can get 1 out of 3 this way. We could also do it like this. The one that the probability of what we're looking for divided by the probability of all that could possibly happen. Okay, so this represents what could possibly happen, all the possibilities. Well, that divided by that gives us probability ratio, which is, again, gives us the correct answer of 1 out of 3. So if I randomly selected a box, I got chocolate chip on the first try, the probability of getting another chocolate chip is only 1 out of 3.